right now we're going to be looking at factors, common factors, and the greatest common factor, and how to find the greatest common factor. So some vocabulary that we need to know is that a common factor is a factor that has two or more numbers shared. The greatest common factor is exactly what our adjective of greatest means, which means we have the greatest common factor is the largest number of the two or more numbers that are in common. So let's take a look at an example. Numbers are always easy to find our example. So if I make a list of all of my factors of 30, I have 1 and 30, 2 and 15, 3 and 10, 5 and 6. Factors of 25 include 1, 5, and 25. So if I look at the factors that I have in common, the number 1 is in common and the number 5 is in common. So a common factor, notice, is red up here. So a common factor is 1. The greatest common factor is the biggest number that I have in common. So that's the greatest common factor. I have two ways that I can find the greatest common factor. One way that I can find the greatest common factor is to make a list. So if I want to know my factors, what's the greatest common factor between 28 and 42, I can simply make a list of my factors of 28. So my factors of 28 are going are going to include, factors of 28 are 1 and 28, 2 and 14, 4 and 7. My factors of 42 are going to be 1 and 42, 2 and 21, 3 and 42 divided by 3 is 14. Alright, so here's my list of factors. So now I'm looking for ones that are in common. So 1 is in common, 2 is in common, 14 is in common. So what's that leave my greatest common factor to be? My greatest common factor is 14. So this is one way that I can find the greatest common factors. I can make a list of my factors. And this is easy enough to do when these are going to be numbers that I pretty much know my factors for. But when my numbers start to get really large, like 292, I don't know all of the numbers because that's a really large number. So when I have large numbers such as 292, using a factor tree might be quicker to do. So with a factor tree, I'm going to break apart. So I know, since a 28 ends in an even number, I know that I can break this into 2 and 14. 14 can then be broken into 2 and 7. Now I'm left with my prime factorization there. Let's take a look at 42. So again, we said 42 up here was going to be, if I divide by 2, is going to be 21. 21 breaks down into 3 and 7. So here is my prime factorization for 42. So again, I'm going to write that in my little boxes here. 28, my prime factorization is 2 times 2 times 7. For 42, I have 2 times 3 times 7. So to find the greatest common factor by using a factor tree, I am going to circle, I say, who has a dancing partner? So I want to know if I have a 2 up here, does my 2 have a dancing partner in the bottom? So indeed, I've got a 2 in my top row and a 2 in my bottom row. So that's going to be important. Does this 2 have a dancing partner down here? Nope. So I can't do anything with him. Does my 7 on the top have a dancing partner on the bottom? It sure does, so I'm going to highlight those as well. Now, I'm with my, so these are my common factors. Now my common factors I'm going to multiply together. So I'm going to multiply 2 times 7 is 14. So the greatest common factor is indeed 14. And that's the same answer we got up top. So I can use a list or I can use factor trees. Factor trees are going to be a better option for us when we start to get large numbers. So now I would like for you to hit pause and you're going to do a couple U-try problems on the next page, and then I'll be back to show you if you got the correct answers. All right, let's see how we did here. I have 2 pieces of ribbon that I want to cut into equal lengths with nothing left over. I have 1 piece of ribbon that's 18 inches long and 1 piece that's 42. What's the longest possible length of ribbon I can cut? So I chose down here to make a factor tree. So my prime factorization for 18 was 2 times 3 times 3. Prime factorization for 42 was 2 times 3 times 7. When I multiply my common factors together, I get 2 times 3 is 6. So what's the longest possible length of ribbon I can cut? 6 inches. Bonus question, how many pieces will I get out of the 18 inches? Well, if each one is 6 inches, I'm going to get 3 pieces. What about out of the 42 inches? How many lengths or how many new pieces of ribbon am I going to get out of the 42 inches? Well, if each one is 6, I should be able to get 7 new pieces out of that. All right. In my last one, I'm going to use a factor tree to find my prime factorization. So again, why am I choosing to use a factor tree? Well, 128, I don't know all of the factors of 128 off the top of my head. So using a factor tree here is going to be a better situation for me. So you can take a look to be sure that your factor trees are the same. And when I list out everything over to the side, this time I'm going to have 2 dancing partners. So I've got 1, 2, 3, 4. I've got 4 sets of 2. So when I multiply my 4 sets of 2, I'm going to end up with 4 times 4 is 16. So 16 should be my greatest common factor between 128, 80, and 48. I will see you tomorrow.